name is Adiyemi Oluwadimilade Debra, the creator of Compass 7.0. And in this video, we're going to be doing corrections to the most recent geography practical exam 2025, which was written earlier this year. If you are new to this channel, make sure to check out other videos. I know a lot of students find MapWork to be very confusing, but I assure you, once you understand the concept, I know you come to love MapWork. So without wasting any more time, let's get on to the video. Study the map of Ijamo district and use it to answer questions 1 to 10. The scale of the map in statement form is, so now this is a map scale conversion question, and the scale we're given is in representative fraction, RF, 1 ratio 200,000. So now let's convert this to statement scale. 1 ratio 200,000 is the same as 1 over 200,000. Now this could also be written as 1 centimeter to 200,000 centimeters, because that's the only way we could cross out the units. If you notice 1 over 200,000, they have to be in the same unit for us to be able to cross them out and write it as a ratio or a fraction. So now that we have them in the same unit, we need our scale to be in the format that we see above, 1 centimeter to x kilometers. And that means that we have to convert 200,000 centimeters to kilometers. If you've watched our video on map scale or you've seen our previous correction videos, then you should remember the equation I told you to never forget anytime you're doing map scale conversions, which is 1 kilometer is equals to 100,000 centimeters. So now if 1 kilometer is equals to 100,000 centimeters, that means 100,000 centimeters equals to 1 kilometer or vice versa. So that means 200,000 centimeters will be equals to 2 kilometers. And so since we know that, that means that we have 1 centimeter will now be equals to 2 kilometers. And then we have our answer to be C. 1 centimeter on the map represents 2 kilometers on the ground. Question 2. What is the approximate bearing of ABA from OZ? Now, first things first, let's identify the places in question and place a cardinal point on them. And now we can see both places on our map. Here, that's ABA, and here, OZ. Please forgive my pronunciation. And now we're going to draw a line connecting them. So now that we have the places in question, we need to place our protractor. But we need to be sure, and we need to place the protractor on the correct settlement. Is it going to be ABA or OZ? Because this is a key part of the question. Placing the protractor on the wrong settlement will automatically give you a wrong answer. So now, as I always say, take note of the word from OZ. So that means that we're going to place our protractor on OZ settlements. And now we'll take our bearing from the north all the way to the line that we've drawn. And that's going to give us option C, 302 degrees. Now, I know that a good number of you guys understand the concept of map bearing perfectly, but there may be some people like me who get confused from time to time. So I want to clearly show how we got this bearing. So we have the places here in question. And now the part here where our line crosses the protractor is 121 degrees. This is how it's going to look like on a clearer protractor. The line will be about here, 121 degrees. And you can see here, I made the line red to make it easier to see. But now that 121 degrees is not our bearing because it's only from the line here to this place. That's 121 degrees. But our bearing is supposed to be all the way from the north to the line that we've drawn, connecting the two settlements. So now we can get our bearing in two ways. Firstly, 121 plus 180 degrees, giving us 301 degrees. Now, 121 degrees, this is what we've gotten here. That is the angle from the line up to this place here, plus 118 degrees. Since you guys know that the total bearing or total angle on a straight line is 180 degrees. So that's how we have 121 degrees plus 180 degrees. Or the second way is if we do 360 degrees minus 59 degrees, giving us the same 301 degrees. So now, as we all know, the angle at a point is 360 degrees. And if we start from 0 degrees on the opposite side, that is from here all the way to this part line that we've drawn, we're going to get 59 degrees. And so showing that on our protractor, because initially to get the 121 degrees, we started from here moving to this side. So that's from this 0 and moving this way up to the line, we had 121 degrees. But now for the second method that we can use to get our bearing, we can either start from this 0 on the opposite side all the way to the same line that we've drawn, and that's going to give us 59 degrees. As you can see, this is 60, but our line is just before it's giving us 59. And so all we need to do is just subtract this 59 degrees from 360 degrees. That's the total angle in a circle, or the total angle at a point. And that's what's going to give us our answer, 301 degrees. And now the answer we got is approximately the same as option C, 302 degrees. So now I'm sure we'll understand the concept of bearing. Let's move on to the next question. What will be the new scale of the map in representative fraction if the map is enlarged to twice its original size? So now this question is a map enlargement question. And if you've watched our map reduction enlargement video, then you should know that enlarging the map will lead to a corresponding decrease in the map scale. That is, increasing the map size will lead to a decrease in its scale and vice versa. So now let's list out the parameters we are given. The old scale, that's 1 ratio 200,000 centimeters, and our factor is 2 since we're enlarging the map to twice its original size. And if the question was reduce the map to a third of its original size, then the factor will be 1 over 3. So now, to get the new scale, we need to remember the formula I gave in the map reduction enlargement video, which is old scale in representative fraction times the factor will give us a new scale, also in representative fraction. So now inserting all our values into this equation, we're going to have 1 over 200,000 times 2 give us 1 ratio 100,000. So now as you can see that when I was calculating it, because remember I told you that representative fraction, we can write it as a fraction form or in ratio format. So I put it in fraction form when I was calculating so as not to make mistakes. Looking at it like this, it will be easy for you to see that you can just cancel the 2 into 200,000 giving us 1 over 100,000, which is the same as 1 ratio 100,000, which is option A. So it's possible that if somebody leaves it in ratio form, they're going to make the mistake of solving it like this, and that person is going to choose option D, which would be very wrong. So by leaving it in fraction form, you're going to make it's going to make everything clearer, and you'll be able to see your calculations better. So in exam, while trying to be fast, remember that accuracy is very important. So this is what I meant when I said that increasing the map size is going to lead to a decrease in its scale because we enlarged the map to twice its original size, but the scale moved from 1 ratio 200,000 to 1 ratio 100,000. But if you actually pay attention to the values, you see that 1 over 100,000 is actually larger than 1 ratio 200,000. You can put on a calculator to confirm. But I just meant a decrease in like the value from 200,000 to 100,000. So now let's move on to the next question. How many tributaries has River Mommy? So now let's identify the river. If we look at our map, we can see that River Mommy is written in two places, here and down here. We can say that the river originates from here because rivers flow from highland to lowland. And now looking at the values of the contour, we can see 700, then it skips a contour, then 600, then it skips another contour, then 500. I'm sure that you'll be able to identify the missing contours. 700, 650, 600, 550, 500, 450, 400. So we can easily say that the contour interval is 50, but that's not the point of this question. So now let me trace out River Mommy to make it easier for us to identify the tributaries before we answer the question. So now let me quickly define the word tributary in case some people aren't sure. A tributary is a river or stream that empties or flows into a larger river or lake. I'm sure based on this, we can all identify the two smaller rivers that flow into River Mommy. Here, that is River Eko, and over here, River Ose. And therefore, we can say that River Mommy has two tributaries. What is the likely occupation of people of the Ijamo settlements? So now let's identify the settlement in question, and it's right here, written in capital letters. Now, for the likely occupation of people living in this settlement, we just need to look around and compare what we can see on our map to the map key. And around the settlements, we can see some zigzag lines that look like this. And on our map key, they represent scattered cultivation. Scattered cultivation means that they were engaged in some form of agricultural activities like farming or cattle rearing, making option B our answer. The area of the map is approximately, firstly, we have to measure the length and breadth of the map. Now, if you notice, we're not going to measure the whole length, including the part that contains the map scale and the map key, because if we do that, that would be very wrong. We just need the part that contains our map. And now on measuring, that's going to give us 13.5 centimeters by 15.4 centimeters using your ruler. So now the measurement we have gotten is for the map, but we need to convert it to actual or ground distance. And for that, we need to recall our map scale, or 1 to 200,000, which we converted to statement scale, 1 centimeter to 2 kilometers. Let's convert this map distance to ground distance. I've already written out the scale and the original length and breadth that we've been given. So since 1 centimeter is equals to 2 kilometers, to get our actual length and breadth, we're going to multiply by 2, and that's going to give us 30.8 kilometers by 27 kilometers. And now to get the area of the map, we just need to use the formula for area of a rectangle, that's length times breadth, and that's going to give us 831.6 kilometers squared. And that is approximately equals to option B, 832 kilometers squared. Now, if somebody had measured the red line and used it to calculate their area of the map, they are going to have gotten a higher number and they would have gotten a value around option A, that's 1,100 kilometers squared, should have been wrong. The distance in kilometer as the crow flies from Ophir to Yacht is approximately. Now, if you've been following our correction videos, you will know that as the crow flies simply means distance in a straight line. So now the next thing to identify are the places in question, that is Ophir settlements and yachts. And then we place the cardinal points on them and we draw a straight line connecting the both settlements. So now on measuring the distance, that's the length of the line, I got 5 centimeters. So now we just need to convert this because this is map distance. We need to convert it to the actual ground distance. And for that, we need to recall our scale, 1 centimeter to 2 kilometers. Therefore, the actual distance between the two settlements will be equals to 5 times 2, which is equals to 10 kilometers. And that makes option B our answer. You can see how easily we solve this question. Now, if someone just hurriedly measured the line and got 5 centimeters and then decided to pick 7 kilometers because maybe they approximated it that 5 centimeters could approximately be 7 kilometers, forgetting that the units are different, they are just going to pick a wrong answer, a very wrong answer. Now, moving on to the next question. The second largest settlement on the mapped area is, this question is also very easy. Now, the largest settlement should be easy to spot, and that is a Ijamo settlement. Now, apart from the map being named after it, we also need to look at those tiny squares beside it. Because if we look at our map key, those tiny boxes represent settlements. And now, looking at the number of tiny boxes there, that tells us that it's a very large settlement. So now to get the second largest settlement of the map, all we need to look for is the next settlement that has the highest number of boxes after a Ijamo settlement. So you guys can pause the video here and attempt to answer the question yourselves. So now I'm sure you all got the answer. So now let me show you why all the other options are wrong. So option A, we've already agreed that Ijamo is the largest settlement. Option C, that's Fada, is made up of 4 squares, while option D, Asebe, is made up of 7 squares. So now while our answer option B, that's Oze, is made up of 9 small squares, you can count it to be sure. Writing out the number of squares makes it easy to see how Oze is the second largest settlement. Question 9. ABS settlement is located in the. Now, this question is very simple. First, let's start by identifying the settlement in question, which is over here. And now I'm sure the answer is clear, but just for explanation's sake, let me write out all the cardinal points. North, east, south, west. Remember, east comes before west, E before W. So now ABS settlement is located in the northern part of the map. And if I wanted to be specific, the northwestern part of the map. Now, the last objective question. The symbol 0.845 in the northeastern part of the map area is known as. Let's identify this symbol that you're talking about in the northern part of the map, and that is located here. So now I know that this may just look like the value of a contour line, but it's not that. It's actually a spot height. These are points on the map where the exact elevation is shown, that is the height above sea level, and it is written as a small dot with a number beside it, which you can see here. Now, if the dot was a triangle like this, which is called a trigonometrical station, which are fixed points used in surveying that have known exact points and heights. But if it was a benchmark, it would have been represented like this, BM 350. So now it's obviously not a valley and it's not a hatcher as well. At this point, you really don't know what a hatcher means. We can explain this in subsequent video lessons, or you can always check online if you're very curious. So now the answer for this is option B, spot height. So now let's move on to the practical geography aspects. Study the map extract provided on a scale of 1:50,000 and answer the questions that follow. In your answer booklet, draw a new outline of the section labeled QRST to a scale of 1:25,000 centimeters. In your new outline, insert and name the 2 minor roads, the main river, and indicate its direction of flow with an arrow, Garin Abba settlements. So that means we're going to give in a map with a scale of 1:50,000. I'm going to redraw a section to 1:25,000. So now I want you to be thinking whether it's going to be a map enlargement or reduction. But before that, let me show you how the map looks like. So now this is the whole map, and let's zoom in and see from the top. We also have a map here at the bottom. This is our scale given to us, 1 ratio 1 ratio 50,000 centimeters, 1 ratio 50,000. And now this is the area QRST that we're asked to focus on, QRST. So we're asked to draw this again to a scale of 1 ratio 25,000. Now this is a close-up section of QRST. The scale of the original map is 1 ratio 50,000, and the question asks us to draw QRST using a scale of 1 ratio 25,000. So now first we need to find out if we are reducing or enlarging the map and by what factor. If you've already watched our video on this topic, then I'm sure you already know that we are going to enlarge our map by a factor of 2. So now we need to measure the size of QRST, and that should give us 6 centimeter by 6 centimeter. So QRST is a square. Now I want to pause for a bit to explain the concept of the scale to those who didn't understand why we're enlarging by a factor of 2. So now this is from our map reduction enlargement video. Whenever we are given a new scale and we have to find the factor, this is the formula we use. Old scale over new scale, or we can use the word on to allow you to remember which is the numerator and the denominator. So if you get a fraction when you do this old over new scale, that means it's going to be a map reduction. But if you get a whole number, that means it's a map enlargement. Another thing to note is that when using the formula, ignore the 1 in the ratio because using it is going to give you the inverse of the correct answer, which is wrong. So now let's solve our question. Based on our calculation, after dividing 50,000 divided by 25,000, we got 2. That's a whole number, and that means that this is a map enlargement. So now we're enlarging the map by a factor of 2. As you can see, I ignored the 1 in the calculation. Remember that if the scale of the map decreases, that means the size of the map is going to increase, and this follows that rule. But if we had done 1 ratio 50,000 divided by 1 ratio 25,000, that's going to have given us 1 over 2 half, which is very wrong. So now as you can see, the length and breadth of our new map is going to be 12 centimeters because we multiply 6 times 2. So now let's draw the outline of our new map. And it's going to look like this. So now that the outline of our new map is ready, all we need to do now is insert the required features. But before that, we need to draw a grid for the map because this will allow us to place the features accurately. The grid boxes should not be too small as that's going to make plotting difficult and it's also going to be time consuming. At the same time, the boxes of the grid shouldn't be too large or it's going to be difficult to accurately position the features on the map. So now as you can see on the original map, I divided the area into a grid of 6 rows and 6 columns, with each box measuring 1 centimeter by 1 centimeter. That means that our new map is going to have the same number of boxes, but the sizes will obviously be different. So now the grid of our new map also has 6 rows and 6 columns, with each box measuring 2 centimeter by 2 centimeters. So now we can insert the features, the minor roads, the main river, and the Garin Abba settlements. Now, as you can see, I have indicated the minor roads in the section QRST. And I know they are minor roads because the map key said so. The major roads are usually striped and not plain like we have here, while the broken lines we can see here indicates minor paths. So don't mix them up. The question asks for minor roads, 2 minor roads, which we have indicated here. Now, thanks to our grid, we're able to draw them in similar locations as seen on the map. The next question is the main river and its direction of flow. Now we can see we have the river here. The main river will be the river that covers the most portion of our section QRST. And now we can see that river here is located in the right side of section QRST. And we can also see that it has tributaries as well, but I only drew out the main river. The next thing to do now is to determine the direction of flow of the river. Remember that I always say rivers flow from highland to lowland. So now we need to look at our map more closely to see which contour lines the river crosses and determine its direction of flow. So now if we look beside line ST, we can see some contour lines. You should be able to see some of them even though it's upside down. At the bottom here, we have 1,500. Just above it, we see 1,450. Then we see 1,400. Above it, we have 1,350. And then at the top, we have 1,300. So now let me make them bolder. 1,500, 1,450, 1,400, 1,350, and 1,300. So we can safely say that our main river, that is this one here, is moving from highland around 1500 to 1300. So our river is flowing in this direction upwards from highland 1500 to lowland 1300. So now don't think that contour lines are only, don't think that because these contour lines are on this side, they're only restricted to this portion of the map, that they don't have any relation to this side. Because these contour lines cross the whole map. So now let me trace it out for those that still have doubts. So now this is the 1350 contour line. It started from here and it extends all the way here. So as you can see, I just highlighted the 1000 and the 1350 contour line. While this contour line around here that the river also crosses is the 1300 contour line. Now let's indicate direction of flow on our map. Now the last thing to add is the Garin Aba settlements. And we can clearly see the settlement here, Garin Aba, it's even labeled on our map. So now, as you can see, thanks to our grid, we've been able to place all the features in their accurate position. The two minor roads, the river, its direction of flow, and the Garin Abba settlement. So now let's just add some finishing touches to our map. And now we're done with answering question 1A and B. Please, the only reason I used colored pens to mark out the features was to make the explanation clearer and for aesthetic purposes. In your exam, always use pencil. Now moving on to the next part of the question. Outline 3 reasons for which Karlahai is the most important settlement in the mapped area. First, let's identify the settlement in question, Karlahi. For all these questions, all you just need to do is look around and answer the question based on what you can see or based on what you can infer from all these features or symbols that are surrounding our settlements. Now, the first thing I can notice are all of these roads that we can see here, as well as the footpaths. And because of that, I'll say there's an important road intersection. So Karlahi lies at an intersection of several minor roads and footpaths. And this makes it a key transport and communication point within the mapped area. It allows for easier movement of people, goods, and services. Now, settlements located at road junctions often grow faster and become important due to their accessibility. Number two, presence of key institutions. Now, if we zoom in, around Karlahi, we can see just at the bottom, we can see DISP, SCH, and CT. And DISP means dispensary, SCH means school, and CT means courts. Due to these things we can see around Kalahai, the second thing that makes it important is the presence of key institutions. So important facilities such as dispensary, school, and courts are located in Karlahi. These institutions serve the surrounding communities by providing healthcare, education, and legal services, which adds to the settlement's overall significance. Now, the third thing that makes Karlahi an important settlement is the concentration of built-up areas. We have a high number of built-up areas around Karlahi. Now, what I mean by built-up areas are all of these patches or shaded grey settlements that we can see all around the roads here beside Karlahi. So now I'm sure that many of you might have seen these symbols before, and you might have even seen it on the map key, but you did not know what it means. Built-up areas, these grey areas that we can see here. These are places with high number of buildings, infrastructures like houses, shops, and offices. So now this shows that Karlahi is well developed and possibly an urban area with high population and lots of human activity, because you can see a lot of it surrounding Karlahi. Now these are all the reasons I gave earlier. We have a lot of roads that meet here. So Karlahi is a place where several roads and paths connect, making movement easier. The important services, the school, the court, and the dispensary that serve a lot of people in the area, and lots of buildings. The many grey patches, which represent the built-up areas that I told you about, show that it's a busy place with lots of infrastructure surrounding it. And now moving on to the final question. Using evidence from the map, identify 3 economic activities of inhabitants in the mapped area. Now I know this question may look a bit difficult, but I assure you that we can find 5, if no more, economic activities of people in this mapped area. So now let's take a look at our map once again. To take note of every single symbol that you can see, everything is important. All those tiny symbols that you can see that surround the whole map, that you can see that fill the whole map at different points of the map, take note of it. Even the dispensary, the school and the court around Karlahi, even the roads and the footpaths, all of them have meaning. So take note of everything. All the symbols, but the small ones, tiny ones, everything is important in finding out the evidence for economic activities. Okay, now let's try to make inference from all this evidence that we've gotten. Now, after looking at the map, let's infer the activities that people living in this area will engage in. For one, agriculture or farming. Scattered cultivation, savanna and orchard bush areas show that people grow crops like maize and yam. So now farming would likely be the main occupation of people in this mapped area because, as I told you, to take note of all those symbols that we saw on the map. So on the mapped area, we saw a lot of scattered cultivation. We also saw symbols that look like this, and now we know that they mean scrubs. We also saw symbols like this, like look like upside down horseshoes. Those ones mean light forests. So the scrub and the upside down horseshoes that we also saw together in some areas indicate savanna and orchard bush areas. And this is the reason why it was said that farming will likely be the main occupation of people in this area because the whole map is basically filled with scattered cultivation and scrubs. The next economic activity, animal rearing. The presence of savanna, scrublands provide grazing areas for animals like sheep, goats, and cattle. So this serve as a source of food and also income for people living in this map area. Number three, forestry. The forest areas, which is indicated by the light forests that we saw, those upside down green horseshoes, they will provide resources such as firewood, charcoal, timber, and non-timber products like herbs or maybe wild fruits. So now we already have three activities, but I'm going to give you some more. Number four, education services. So now don't forget that the SCH that we saw that's around Karlahi means school. And if there is a school, that means that they're going to employ teachers, administrators, and even supporting staff like cleaners, gardeners. Number five, healthcare services. Also, don't forget the dispensary that we saw where we could get drugs. And then number six, CT, the courts, legal services. The CT that means court, therefore means that there is a presence of a legal system in the mapped area. Now we also have trade or commerce activities. Now don't forget those built up areas that I told you about because we also see them on the map, those shaded gray regions. As I said before, the built up area simply means places where people live, work, and there you can find many buildings close together. So obviously those people will engage in different trade or commerce activities. And last but not least, transportation services. So all those roads that we've been looking at, they actually have meaning. And now, as you can see, we're able to get not three, but eight evidence to prove the economic activities of people living in this mapped area. Now, since the question asks for just three, I would advise you to combine the ones for farming and animal rearing and just make it more points. And then your second point could now be institutional and administrative functions, where you can mention the presence of the school and the courts and the dispensary as one point. And then for your last point, number three, can be you can either choose to mention maybe the transportation or the built up areas, anyone. But if the question had asked you to list out maybe like five or six economic activities and the evidence to support it, then you could have written it out like this. You could have spread it out the way I did here. And with that, we come to the end of our video. So please take your time to understand any of the concepts that you may not have found easy to grasp the first time. And if there are any topics you want me to make videos on, please type them out in the comment section below. Make sure to like, share, and subscribe. Thank you.